going to talk through some examples of the use of Meshgrid, looking both at the indexing and why we use it, so the speed. So we're going to start by just defining the standard variables that we always put at the top of it. Well, our Jupyter notebooks, you do matplotlib inline, which sets up the notebook to put the diagrams in the notebook. And then we're just going to import NumPy as NP and the standard matplotlib pyplot module as PLT. So what we're going to start with is a very crude and simple grid. We're thinking about 2D grids at the moment, the kinds of things that we're going to use to solve differential equations and all sorts of problems in physics. So they're really important to understand. And we're just going to set them up as a simple x linspace from 0 to 7 with 8 points. That'll give us integer spacing, and y is going to be a simple grid from 0 to 3 with 4 points. This will make the grid non-orthogonal, i.e., sorry, not non-orthogonal, non-ortho. Well, not the same size, not square. It'll make it rectangular. That's the word I was searching for. The obvious way to plot this grid is just to have a couple of for loops. So let's do for x point in x. That's a standard Python way of iterating over an array or a list over an iterable. And then we'll do for y point in y. And then we'll just plt.plot at x point comma y point. And I'm going to put in a line style. I'm going to force it to be a black circle. So K, remember, is black. There's a standard convention that CMYK means cyan, magenta, yellow, and black. And if we do that, then we get a plot like this. Now, that's not a helpful plot because it's not equally scaled. The axes aren't right. So we're going to put in the command plot.axis scaled. That makes it square, which is exactly how we want the grid to be. Let's put some labels in. So plot.x label will be x, plot.y label will be y, and we'll put a title, and we'll call it an example grid, let's say. Okay, there we go. There's our grid. Now, how would we highlight a particular point? Well, what we'll do is we do plt.plot of x of 4, let's say. So that's going to be x equals 4, y of 2, so y equals 2, and let's make it a red circle. And there we go. There's our red circle. That's at x equals 4, y equals 2. So far, so good. But this is not the NumPy way of doing things. This would be quite a slow way of doing distances. I'll show you that in a minute. So we have this alternative, which is Meshgrid. And the way the syntax works is we say x2d and y2d. So that means that Meshgrid is going to return two arrays, is equal to numpy.meshgrid of x comma y. It's as simple as that. You run that, and we now have these two arrays. And we can plot this grid, so plt.plot of x2d comma y2d comma quote ko, exactly as we did up here. But notice that we now have a single command because we've put all of the arrays into one place. And we get the same problem we had before. So let's scale the axes. In fact, I'm just going to cheat and copy all of this here. There we are, same example grid, but let's actually just change it here and say from Meshgrid. And let's put in our point again. So before up there we had x4, y2. So let's do plt.plot of x2d of 4,2, y2d of 4,2, and we'll do a red circle. We get an error. Now, what's going on here? Okay, well, let's just look at the error. So the green arrow here shows us where the error is. It's in our plotting, and we're told that the index 4, which is going to be this 4 here, is out of bounds. For axis 0, that means it's the first argument with size 4. And what's happened is that we've assumed something about the way that Meshgrid works. We've assumed that Meshgrid will obey the kind of indexing that seems logical to us. And so let's just print what those arrays look like. So print x from Meshgrid. if I could type colon space, and I'm going to put a \n, which means put in a new line, a character return, and run that. And now we see something interesting. So what we have is we have a 2D array, and at each point of the array, the value of the array is the x coordinate of that point, which makes sense. It's how we can plot the grid. But the indexing is the other way around to what we might naively expect. So you'll see that we have 4 rows and 2 columns. Let's just check that we understand that correctly by plotting out y. So here's y from Meshgrid, and there's a \n again, and we'll put y2d. And yes, okay, again, we see that at every point, every entry in the array is the y component. We'll come back to the ordering in a second, but it's with a row, column format. So we want, if we're going to go to this circle here, as we did before, we want the second row and the 4th column. So let's just change this to 4. You've got 2, 4, and run that. And now it says RO not defined. That's because I didn't put quotes around it. And now we have the red dot exactly where we wanted it. There's just a slightly intuitive change in the indexing. We can use another plotting command, so plt.imshow, so that plots a 2D array, to plot the 2D. So let's do imshow of x2d, and we see that we have some stripes which are equivalent to this array up here. We haven't got any kind of index telling us what the colors are, so let's put a plot.colorbar there to make sure that we know what those mean, and let's put a title. It's going to be a 2D array of x positions. Okay, there we go. Now our color bar shows us that dark blue is 0 and yellow is 7. And so we can see that these are columns from 0, 1, 2, 3, all the way up to 7. And if we copy this and change the x to a y, then we will get what we would expect there. So we can have a 2D array of y positions. And lo and behold, yes, okay, so we get exactly what we wanted. We see that we go from dark blue 0, 1, 2, and 3. Notice that the origin is in the top left. So with imshow, you can change that. You can do origin is equal to lower, and that flips it around and puts the origin in the bottom left-hand corner. If we look particularly back at this y array, you'll notice that the 0th row is equivalent to y equals 0. And of course, the ordering of how this is printed out is opposite to what we would normally put in a graph. There's nothing wrong there. It's just not quite what we would expect. So let's just insert a little text comment here and say, you know, the key thing here is that by default, NumPy.Meshgrid returns arrays with row column ordering. So let's put that as a R,C, a fake bit of code. So that's a useful kind of aid memoir. You can run Meshgrid in a different way. And I'm just going to copy some code to speed this up. So what you can do is you can tell it that you want the indexing to be intuitive, if you like. So I'm going to call this x2d ij, y2d ij, and I'm going to give this extra command indexing ij. And then if I plot that, okay, I get exactly the same kind of grid as I got before, but now let's try putting in a single point. And let's say it's x2d ij of 4, 2, meaning I want x equal to 4 and y equal to 2. And let's do y2d ij of 4, 2, and let's give it a red circle. And now that works in the way that we would intuit, the way we would expect. What's actually happened to the arrays? Well, let's just actually print them out. So the X array with ij indexing. Again, we'll put the \n because otherwise it gets a little bit confusing. Okay, and what we see is that we have simply changed the order of the indices. Okay, so you know, again, we have every point on the grid is the x coordinate of that point, but now we can put the 4, 2, so we can go to the 4th row and then the second column, or actually because it's a +1, it's the fifth row and the third column. Okay, so that's how Meshgrid indexing works. It's often simplest just to sort of stick with the standard arrays, and if you need to pull out a particular point, just remember that it's row, comma, column. Why do we do Meshgrid? Well, let's put a little heading in here, just to encourage that. So here's speed of operations, and let's actually sort of define a situation where we've got, say, 300 points, and I'm going to say that x large is numpy.linspace of 0,1, n. I say that y large is numpy.linspace of 0,1, oopsie, 0,1, n. So I'm going to make this square this time because we're not worrying about the indexing, we're worrying about the speed. And now I'm going to introduce a matplotlib, a Jupyter Notebook piece of magic, or an interactive Python piece of magic, they call it. I don't like that term, but it's prevalent. Basically, this will time the operations here. So let's set up an array to do a distance. We're just going to calculate the distance to each point in the grid. So we're going to have numpy.zeros of n, n. And now we'll say for I and let's say xv in enumerate XL. So what that's going to do is that's going to go over the array XL, and for each point in the array, it'll return I, which is the index, and then it'll return the value in XV, and then for J, comma, YV in enumerate of YL, and then we're going to say that RA of I, comma, J, and now you see why we wanted the indices, is equal to numpy square root of XV squared plus YV squared. And let's run that and it'll return to us the time it takes. Okay, and on my MacBook Pro, that takes 100 milliseconds. Let's now see what happens with Meshgrid, and we'll include the generation of the grid in the timing. So we'll say x2dl, comma y2dl is equal to numpy.meshgrid of xl, comma yl. And then we'll say that the distance, we'll give it a different name, RB. So this is the same distance as numpy.square root of x 2dl squared plus y 2dl squared. Run that, and it's 2 milliseconds. So that's nearly 100 times faster. And you can run this several times. You can increase the size of n, and what you'll see, and you'll see that there is this speed difference. It really is extraordinarily fast. This is why we use NumPy arrays. This is why we use Meshgrid, is because we can go from a loop with indices and individual element calculations to a single line without any indices and just a simple calculation, and is much, much more efficient. Let's just do a little bit more and just talk a tiny bit more about plotting. So let's just think about how we might plot the distance. So if I do plot.imshow of RB, okay, we see that we get a color. We need to put on the color bar as always. Plot.color bar goes on there. So now we see that. Really, we want to have the axes showing the distance. The way that you do that is you specify the extent. So you say extent is equal to, and then it's just 0, 1, 0, 1. We might want to define the limits up here where we first set x and y and put those limits in there to be safe, so that if we change the limits, we don't have to keep changing the numbers all the way through. If we do that, well, now we get something slightly odd, because what's happened is we've got the origin in the upper left, but the origin of the extent is in the bottom right. So what I'm going to do is I'm going to change this and say origin is equal to lower. And let's put a title on. So distance from the origin. And we should probably also add labels. And plot.y label. Y. Notice that you can use double quotes or single quotes for strings in Python. Now, to me, this is actually quite difficult to work out what's happening. The change of color doesn't really show what's going on. There's an alternate plotting technique we can use, which is to use contours. So the simplest example is plt.contour. You have to give it x and y. So you give x2d underscore l, y2d underscore l, comma rb. And I'm going to say levels equals 20. So I want 20 contours. And if I do that, okay, so now what we're getting is a contour plot. The color of the contour plot denotes the value. So we need to put a color bar in. And also we want to have a square plot. So plt.axis scaled. Okay, so that's now nice and square, and we've got some contours, and we've got a color bar showing us the values of the contours. That's okay, but what we can also do is we can do what are called filled contours. So we just change that to contour F, and when we plot that, then you can see that we've got something very similar to the IM show. We've got a certain number of levels, but now we can actually sort of work out what's happening in terms of the color change from point to point. You can, of course, increase or decrease the number of levels. So if we change it down to 10, I think perhaps that's a little coarse. If we were to take it up to 100, well, then actually is almost indistinguishable from the plot.im show. That just demonstrates that when you're plotting and presenting data, you have to think about how you communicate what we know about what happens. That's all I wanted to say about Meshgrid. I've added a little bit about 2D plotting. You can, of course, do Meshgrid on 3 dimensions as well. You can read the documentation on Meshgrid to see how that works, but it's very, very similar.